Hello and welcome everybody to the new video analysis tool that we have inserted into Analyzer 26. This was originally thought of to be a version 27 feature, but it's been done for quite some time now. And I wanted to get your feedback on it so I can still iterate a bit and we see where we can still improve usability and also maybe capabilities. All right, so the new tool is a manual video analysis tool that can be used to analyze frames of any sort of video. So it doesn't need to be any specific kind of video. It can be dashcam, can be GoPro, can be from a CCTV camera, can be a phone recording in any format. And the tool enables us to read individual frames, analyze the frame rate, and also track individual participants frame by frame, and help us extract speed information about cars. So what I'm going to use to demonstrate this is an example from one of our seminars. So there was a collision here in this area between a car coming from this road down here and one car coming from the left here. The car coming from down should yield to the car coming from the left. And we have a CCTV camera somewhere around here that is recording this whole thing. The video footage I'm going to show you very soon. In order to start the new video analysis tool, you go to Modules, Video Analysis, Manual Analysis, Single Frames. And then you see this dialog where you first want to load a video. This can load any video, so AV, MP4 should all be fine. And this is the video in question. After loading it, first on the left side here, you get some information about the video. So what frame rate, the actual frame rate is used, the average frame rate. Oftentimes videos have variable frame rates. So you see what you have in front of you. This is the typical 29.97 frame rate that comes from old TV conventions. We can play the video, and then you see the play bar here advance and also the frame number go up. So this is the video in real time. Be careful that you have to have a video that is actually also real time here. So the video you're playing back should also be real time if you want to use this as a real time analysis tool, obviously. Let's go back where the collision happens. So you see the car go down this road, enter the intersection, and then the car on the left crashes into it. The first thing I want to do is I want to see the exact frame at which collision happens. So you can zoom here with the mouse wheel in this video, and you can also shift it around with the middle mouse button. And this, to me, is the frame in which the collision happens, or the closest one. And then I'm going to click here on the left, set collision equals 0. Click. And now I have this time, 6.507 seconds after the start of the video, synchronized with my collision. So I can go back, and now I always see here in the analyzer convention, meaning positive time is the time to the collision, time 0 is the collision time, negative time is time since the collision, post-collision. I can always see how long I have until the collision happens. Then 0 is the collision, negative is the post-collision. Okay. What can I do with this now? I can do a couple of things. First, I can export individual frames here. So I can analyze individual frames. I can go to frame, let's say frame 100. And then I can put that frame into the scene. And since here we have collision time, frame number, and time from start checked, it will also write that information into the frame. So I've now clicked to export that frame, frame number 100, with the time and the time to the collision into the video, into the background. So that is something I can now use here, or used to show something, right? So this is here. Is what we could say. I can also do that for every single frame in this video. So if I want to do this for every single frame, then here in the bottom, I can export all frames. So if I click that, it will write every single frame as a PNG into the folder where I loaded my video from. And it will also add the frame number, the collision time, and the time from start to that, just like we have here. I'm not going to do that. I'm not going to load that now or show you, but that is what happened in that folder now. I can also list all the frames. So here I can look at the frames when they start, the frame duration individually, and the synchronized time to collision of that individual frame. I can also export that as a CSV for whatever reason if I want to do that. And I can also embed the video into the 2D. So not just a single individual image, but I can also embed the whole video into 2D. Always gets created here in the center. So this thing, this object here, it's something completely new. It's not an image. It's rather an updating video that is synchronized to Analyze. So because we set the collision time at 0, and my time down here is now 0, this shows me the collision. If I were to add some vehicles, we always see the time only advance when we have actual vehicles doing something. Let's say I have 10 seconds of a standstill car that I'm just going to create as a dummy vehicle to show this. And I'm going to synchronize it so it also has some post-collision. Okay. Now, I'm going to make the video analysis smaller. Now I have in the 2D background here, I have this embedded video that is synchronized with the time slider in Analyzer, as you can see. So I now have a synchronous video with my 2D simulation. I haven't done a simulation yet, obviously, but in the end, I could show this side by side with the actual cars driving. So that's pretty cool. This, by the way, can be treated just like an image. So you get this bitmap tab here where you can make this, I don't know, semi-transparent for whatever reason if you want to do that. Or you could cut it, so you could remove stuff from the sides, crop, make it into a negative, all those things, color, contrast, correction, stuff like that. And finally, the last thing we can do in the video analysis tool is we could do some vehicle tracking. So in this bottom left side, I can activate the crosshairs. So here now I have some crosshairs that I can use as reference marks for positioning. And then I can click on vehicle tracking, which makes the dialog only half the size. So I can see on the right side still the background. And then I can advance the video with this small tracking dialog that also has a play bar, as you can see. I can advance it to any frame I want, and I'm going to start with the collision frame here, 196. And I'm going to set the vehicle at that position. So I'm going to click Set Position. And then with my mouse cursor in the scene, I can left click. And now this frame, 196, the collision frame, has been placed for vehicle number 1, which in my case is this black one here. Then I advance it. I'm going back in time because I care about the pre-collision. Go back a bit more to this frame, for example, before it turns strongly. Click Set Position again, and then left click that new frame for that vehicle into the scene. Of course, I'm not doing this as precisely as I would in a real case, but it's just a demonstration. Going back again, here when he's parallel with the road and entering the road, set position, left click. Obviously, the more precisely you can do this, the better the results. This is not super precise for me now because also the video is not so great showing this area. Going back some more, we have this mark here on the left, which should be here. Set position, click and rotate. And going back even further, the car's front tire is now at this black vehicle, which isn't actually black, it's this blue one here. Set position, click. And it should be roughly here. And when we're done, we can click path plus speed, and then we get the speed in this interval, the average speed between the two set positions, because we know the time and we know the distance, thereby we know the speed. And that is the average speed here. We also get a transfer into Analyzer. The transfer doesn't happen at constant velocity though, because the transfer has to be matching time plus matching the distances that need to be covered, plus also the individual phases need to have a smooth speed transition. So there we interpolate with multiple phases of braking and acceleration or constant velocity to get the right distances and the right speeds. Of course, those are based on some assumptions, namely that we have smooth transitions over those distances and times. The more positions you set, of course, the more precise this becomes, because the less smoothing we do with averaging out the speeds, but we get the actual speeds that might change in a bit of a different manner. Okay, so I'm done with the tracking. I can close it, and now I have this vehicle here. And it's synchronized. Let's see. What do we have here? Boom. With the video. So yeah, that is the basic way of using the video analysis. You can also use it to track dashcam footage, to track the car in the dashcam or any other car that you might see from the dashcam when you can overlay it with something in the background, for example. Also, something I didn't talk about is the option to do lens correction. If you have a fisheye lens here, you could set the rectification matrix for the fisheye lens parameters. When you click use correction, it will try to rectify a fisheye lens here. This obviously doesn't quite work. With these parameters, I would have to play around. There's slight fisheyeing in this CCTV camera, but I'm now not gonna bother with this. It's just an option I have. All right. Thank you, and I'm looking forward to your feedback.